Hey everyone, this is a quick video presentation of the cloud computing assignment. Our business idea for the cloud computing assignment was a cloud-based timesheet management system where users would be able to input the employee IDs, numbers, and the number of hours they've worked, and it'll be stored in cloud that would be more cheaper and efficient for companies to use. The presentation will be talked about by myself, Lachlan Chu, and my partner, Lucas Lim. And we'll be kind of going into a bit of detail of the architecture we use and the deployed services that we'll be using of AWS. And we'll have a bunch of screenshots so that you can follow through with us and not get too lost. And we'll also be showing some of the challenges we may have faced and how we kind of overcame them as a group. So this is basically the architecture and deployed services we used. We used AWS implementation. We're learning about it all semester, so we're kind of using all we've learned throughout the semester to implement our business idea. I'm going to brush through them quite quickly because we'll go a bit more into detail when the slides come up. But just from left to right here, we've got the IAM, which stands for Identity and Access Management. We have our VPC and EC2 web server setup, the web feature deployments, instance scaling and monitoring, storage expansion backup, the database integration, which we used Amazon RDS, and the auto scaling and load balancing.
In this section, we were given the task to assign all roles and permissions to the predefined lab role IAM role, but we had several issues with this section. So firstly, we were not given the permission to create users or groups. So we were unable to add multiple users to access the AWS services. Secondly, we were unable to change permissions pertaining to the IAM role lab role. So we couldn't assign any permissions to it or make any changes to that lab role. As well as since no users could be created, we were stuck using the root user, which was named main, and that had unrestricted access by default, which the IAM role does not affect at all. But the access to AWS services was still controlled by security groups. So hence, with the rules set by security groups, you could limit access of the root user to AWS services.
So here we're going to talk about the VPC and EC2 web server setup. Really, this was kind of three separate sections where we have the EC2 instance, the VPC, which stands for Virtual Private Cloud, and the VPC security group. All these three kind of work in conjunction with each other to kind of bring alive the web server. So I'll go into detail to them now. The next section here is the virtual private cloud, which is a VPC. A quick description is that it's an isolated network that allows us to launch AWS resources. These resources including our EC2 instance. So it's quite important for the development of our web server. Here on the right, we have a picture just so that you can kind of follow what type of configuration we kind of did. A lot of it was provided by the assignment sheet, but just in case you wanted to follow with us, that's kind of the structure and the preview of what it should look like. The next section here is the VPC security group. We've got a quick description again. The security group acts as a virtual firewall managing the inbound and outbound traffic. It's quite important as the question itself only wants us to include HTTP and SSH, only allowing those ones to gain access basically to the VPC, which will eventually be giving access to the web server. So we've just kind of shown this kind of simple configuration. It's quite easy to follow and it makes it quite easy to choose with AWS features. The next and final section for the VPC and EC2 web server setup is the EC2 instance. A little description on the right here. The EC2 instance serves as a virtual server that hosts and runs applications. The application that will be hosting and running will obviously be our web server, which allows users to input the employee ID and number of hours they've worked. It's also really important to note that the security group and the EC2 instance work with each other to control the inbound traffic. So we were talking about the inbound traffic before and which ones we're allowing through. And so it's important to have the EC2 instance work in conjunction with that as well.
So the web feature we decided to implement is a tracker for the number of hours employees have worked. Companies will have the ability to add entries that consist of the ID of the employee, the number of hours that employee has worked, and the time at which the entry was made. Entries are also able to be updated, meaning that they may alter the number of hours an employee has worked as a corrective measure. Finally, they may also delete entries that prove to no longer be useful. All entries made will be stored in a connected MySQL database so that when the site is reopened at a later date, all entries are saved.
The next task we had to focus on as a group was the instance scaling and monitoring. Uh, Basically, this meant that we had to adapt our infrastructure to meet increasing demand or what could be increasing demand. And let's have a look at the next slide here. Uh, this one talks about enabling termination protection. Quick description about termination protection. It simply just protects the instance from being accidentally terminated. So this is quite important as you obviously don't want your instance to be deleted. So we had that enabled. We also had upgrading instance type. This would allow our instance type to improve in CPU power, memory, storage, and overall performance. We originally had it there in the photo you can see as 2t.micro, but we'll be updating it or upgrading it to 2t.small, which gives it a bit more performance. We can also see here that we're monitoring our performance and systems logs. We've got the graph on the left here. This was from the instance on the console page, where it just kind of shows us a bit of uh, of the performance and what we can keep a look at. And then on the right, we've got the system logs, which are important for tracking events, errors, user activities, and obviously the system performance. The next task is the storage expansion and backup. This is obviously quite important as if a company is quite big and has a lot of employees, or if they're changing employees, they're obviously going to be expanding the amount of storage they need or decreasing, and we obviously would like a backup just in case anything does happen. So here we have the EBS volume. The EBS stands for Elastic Block Store, and essentially just acts as a virtual hardware or hard drive that will be attached to the EC2 instance, and it will basically save the EC2 instance or kind of save some of the storage, which we can use later as a snapshot to recover it. Here we have a kind of photo down below of what our EBS volume would be. We've called it my volume here, so that's important to notice. This is us configuring the file system. This was just us simply adding a text in. It was quite simple. We did it. We just did an example from what the lab did, but obviously you can uh, configure it so that it could actually store more important information. But yeah, we just wanted to show you that we can do it. This was us creating the EBS snapshot, which obviously I said before is how we would recover the storage. This was quite easy and simple, and then we also um, show us restoring it there on the right there. The next one would be the database integration. And we use Amazon RDS. This can be split into kind of three sections here, which is launching a MySQL RDS instance. We can also configure the database security group, and then the final stage would be ensuring the EC2 instance is successfully connected. So this is quite important for actually storing the information. So the MySQL RDS instance creates a cloud database, basically, and it will be connected to the EC2 instance. So yeah, this was just a photo of us creating a RDS instance. We have here a database security group. Um, as the previous one, the VPC security group, it also acts as a virtual firewall for the database and basically manages its inbounds and outbounds. So it's essentially does the same thing that the VPC security group did. This was us ensuring the EC2 instance and database are connected. Here we have a photo just showing that it's successfully connected. This was quite easy and simple. Yeah, not that bad.
In this next section, we implement autoscaling and load balancing. Autoscaling and load balancing enable applications to handle varying levels of traffic while maintaining high availability and responsiveness. An AMI acts as a snapshot of your server. If something goes wrong, you can restore or relaunch a working instance from the AMI. Essentially, it's a backup of the server. An automated load balancer involves 3 steps: creating a target group, creating an application load balancer, and finally creating a launch template. In AWS, a target group is a logical grouping of resources, such as EC2 instances, IP addresses, or Lambda functions, that a load balancer routes traffic to. In short, a target group tells the load balancer where to send incoming traffic. A load balancer is a system that automatically distributes incoming network traffic across multiple servers to ensure no single server is overwhelmed. In AWS, this is typically handled by the Elastic Load Balancer, also known as ELB. A launch template simplifies and standardizes the process of launching EC2 instances by storing all required settings in one place. An autoscaling group uses it to automatically add or remove instances based on the traffic. A load balancer distributes traffic across these instances, using target groups to track healthy ones. Together, they ensure your app stays available, responsive, and cost efficient. Amazon CloudWatch is a monitoring service in AWS that tracks the performance of your resources. In our setup, CloudWatch monitors metrics like CPU utilization on EC2 instances behind the load balancer. If the system is running smoothly, CloudWatch shows the state as okay, meaning no alarms are triggered. But if the average CPU usage goes above 60%, CloudWatch triggers an alarm, which notifies the autoscaling group to launch additional instances using the launch template. This helps handle the increased demand efficiently. In short, CloudWatch plays a key role in automatically scaling the system by monitoring performance and triggering actions when needed.